Yeah, welcome everyone. Actually, 24 hours ago, I did not know I will be standing on this stage as Oliver Hofmann was planned for this speech, but I think as we all love production and 3D printing, we will have a good time together presenting about the challenges and opportunities about the 3D printing in our company and together with Materialise.
Yeah, thank you, Kai, for stepping in so short notice. Robert Hofmann has a very long tradition in 3D printing. And before we go deep into the topic, maybe you can give us a broad overview.
Yeah, so Robert Hofmann is a company which was founded in the 90s, early 90s, by the Hofmann family, and it's today a family-owned company. You can see the numbers with the number of employees and the revenue we have. We have 4 focus areas, which is aviation, medical, the automotive industry. We call it mobility and logistics, as there are a lot more things to automotive than just the normal personal vehicles. And then we have the consumer and industrial parts. We have a broad experience and a long experience with 3D printing in metal and polymers, and we'll dive in shortly.
Ever since back then, Materialise and Robert Hofmann share a really close relation since day one, basically.
Yeah, we have more than 30 years of common and joint history. As everyone knows, it started with stereolithography, and it's not the idea to go into the past, but the topic is challenges and opportunities of 3D printing. And we're at the point where we are today because of all the work which was done the last 30 years regarding software, regarding machines, material. And we are looking forward to push the boundaries forward, and we'll see what we'll have in the future.
I'm pretty sure that in the future we will continue our close relation and work together on the efficiency of the digital workflow. So Robert Hofmann has a really deep knowledge about 3D printing, but you're also very familiar with, let's call it, the conventional or traditional manufacturing methods. I would like to know how you see or define the role of 3D printing.
Well, we heard it already in different talks today, and also already said it today. 3D printing is one of the engineering tools or production tools from our toolbox. So the topic is challenges and opportunities of 3D printing. And on a really high level, the first biggest challenge and opportunities to really understand 3D printing and the benefits of it, you actually have to understand the limits and the possibilities of the other technologies. So if you don't know what injection molding or casting or milling is capable of, you will never have success in 3D printing. So that's why we brought this slide. So understanding the whole world of production and manufacturing processes is most crucial part to understand or deep dive into 3D printing. And if we talk about the overview of just 3D printing technologies, AM Power has a really nice overview of all the possibilities we just have within this one square. So even understanding what are the possibilities and the limits of in each of those 3D printing technologies, this is most crucial to understand and to help the customer what technology he can use for his special use case. So some technologies are really good for one thing, but really bad for another thing. So our daily approach as a service bureau is to really understand what the customer needs, and then out of this whole toolbox of manufacturing processes, to select really the one which is most helpful for him at this point of view. I talked about this first level. The second level, challenges and opportunities, is something everyone knows. Prototyping is state of the art. Prototyping is something we use 30 years for 3D printing parts. What is growing, actually slower growing that we expected, is the aftermarket. So there are a lot of ideas and a lot of products which are already 3D printed for aftermarket. But due to the documentation and the things and the challenges, they come from serious production, from another technology. They try to implement this into 3D printing for aftermarket, and this is no success story. So you really have to do your homework and understand what is 3D printing capable of, and adapt your drawings, adapt your process to bring in 3D printing for aftermarket. And so everyone is looking for applications in 3D printing, and what is really crucial to understand, we do prototyping 3D printing, then the quantity rises and we are in other production technology. Then the quantity goes down and maybe we can go back to 3D printing. So from our point of view, the most crucial thing is to understand where is your dotted line. So at which point regarding material, regarding quantity, regarding customers' expectation, we have to switch technologies. And can be an early part, which is 3D printing, but in no case at all the serious production will be 3D printing. So don't even try to sell the customer a 3D printing solution, because you know that injection molding, milling, whatever is more beneficial. So what we are actually looking for is applications where the quantities are lower. We want to go to niche markets where we really understand that the dotted line comes together, and at one point there will not be a dotted line anymore. So we develop a product starting from the prototype into serious production until aftermarket, staying in one technology. We do not have any efficiency losses from changing production technology, but this is something which will not happen in mass high volume production. So this is the second level of challenge and opportunities that we see right now.
So what you're basically saying is that it is often better to look for those niche market projects than to continuously chase the holy grail of serial production. Can you give us an example of such a niche product that you made profitable or successful?
Yeah, everyone is talking about aerospace and flying to the moon. We brought together a quite funny application from the horse market. It's an English word. Actually, I did not know before, equestrian sports. So for the native speakers, this is a word everyone knows. I did not know equestrian means horse sport. So a customer came to us and said, well, usually we have a leather part for the nose of the customer, of the horse. And especially for the really professional horse riding, this is a problem regarding the pressure on the nose. And we said, okay, this is a really crazy application, but let's see what 3D printing can do. And we continued the approach with the customer. So we first scanned the horse, part of the digital workflow. We had different prototyping iterations with the goal to reduce the pressure on the nose of the horse. So you can say this is quite strange. We did intensive testing, intensive iterations, and also simulation, where the distribution of the pressure for the horse actually improved. And one of the results is that 60% of the point pressure on this horse is reduced. And today this is an application where we produce up to 4,000 pieces a year for an absolute niche market. No one talked about horse sports before, equestrian sports. But this is one really, really nice example where 3D printing can be used where no one expected 3D printing. To have a better overview of the part, we brought a little video of the details. You can have this fly through the part. It's a TPU printed multi-thread fusion part where the weight is distributed with those honeycomb structures.
Yeah, indeed. It looks like a product or a part that would be a nightmare to manufacture with injection molding. And in my opinion, a good example of a product that without 3D printing will not be possible in that way.
Yeah. So the part started, we went into serious production of this part with all the post and pre-processing which is necessary. The different advantages of 3D printing I mentioned, time to market and everything which is needed is a full 3D printed part for serious production. The topic customization is also done in this project. And what is really nice, which we did not expect, that there are a lot of other parts on the horse which can be used in the same manner. So nowadays it's not only a nose strip, it's also a neck and a chin strip, where the same approach, the scan, the software, the product development with the honeycomb structure is exercised.
Yeah, in this case, 3D printing indeed played a crucial role, I think. And it's a good example of a product that without 3D printing, again, would not be possible in a similar way. And it is a good example of the capabilities of additive manufacturing in general and the opportunities that come with it. The efficiency of such a project or profitability, how does the digital workflow define that in a way?
Yeah, the digital workflow is actually really important. I talked about this first level, knowing your technologies, the second level, knowing your market and the customer needs, and the third level for regarding challenges and opportunities is to understand your whole 3D printing workflow. So start with the software, knowing the benefits and knowing the limits of your software. Conventional software usually is not developed for 3D printing application and 3D printing design. And then knowing your pre-processing, your post-processing. So really understand the whole process and value chain and the limitation within this value chain to exercise the application.
Since you also do metal 3D printing, do you happen to have a similar project in the metal application?
Yeah. One example we brought for metal is everyone knows the conformal cooling. So this is not something I will not talk about today. I will talk about a similar approach for particle form parts. So everyone who knows EPP or EPS, so expanded polypropylene, expandable polystyrol, it's processed by steam chamber. So you inject water steam into a mold, and then with this process you get a part where your foam particles are glued or merged together. So as you can see here in the picture, drilling or EDM a mold with all those million of holes is almost impossible. Also, the expectation for material characteristics for injection molding, for example, is quite difficult due to the high pressure. But in this case, the steam process does not need that much of material characteristics. It only has to be stainless steel because of the steam. And then we have molds where we use lightweight to have less material to be processed in 3D printing. The whole energy consumption is a topic for steam application which concerns everyone, especially during the last 2-3 years of energy prices going through the roof. As I said, we have a huge number of small holes which are almost impossible to conventionally produce. And also one big benefit using those type of molds is to reduce the cycle time. Due to less mass, you need less time to bring it up to the temperature, and you have less time to cool it down. So in the end, you save a lot of energy and can produce different foam applications like this example here in the slide.
Yeah, it's a great example of a metal part that without 3D printing would not be possible in any way. And then, as I understand correctly, that is only one example of a whole product family again. Like that is only one EPP application that you're doing, right?
Yeah. So everyone who has to be to physiotherapy might know the black roll product, which is on the market a few years. So the challenge in going back to the niche market, is that we do not produce the black roll, we do not produce the 3D printed part, but we produce the tool. And in this case, as it is a medical or physiotherapy product, you need an even distribution of the density of this part. So someone who is using the black roll cannot have one part which is slightly less dense than the other one. So this technology is crucial in using 3D printing. So all the black roll parts which are on the market are produced out of this type of molds with millions of holes and the steam EPP process.
So you're basically saying two very important things, in my opinion. So number one is you need to know your market-customer needs, as well as the capabilities and benefits of the technology you're going with. And by combining both of those, you can be successful or even more successful in niche application markets than chasing the holy grail of serial production.
Yeah. As I said and tried to mention that the first thing is you have to understand the limitations of your technologies, to deep dive into the possibilities of 3D printing in the broad area of materials, technologies, and that's why conferences like this are so important. The second one, you have to understand, talk to your client and understand which is really his need. Do not print because it's cool or just a hype. Really try to get a solution for the customer, and 3D printing can be a solution. And the third thing is to understand your process chain and be an expert in your process chain to really push the boundaries and the limits.
Yeah. So what would you say, I want to come back on the process chain here, in the near future, a field of improvement, in your opinion, needs to be to enhance the digital workflow even further?
I talked about the dotted line where you switch technologies. So to really have more applications and be more efficient, Audi said that the price has to drop by 100 times or 200 times. And this is what we also see. Many applications will not and cannot be done in 3D printing due to simple pricing. So there are a lot of things to work on in the process chain, starting with materials, starting with machines, parameters, and so on. But the manual work you have on the software side is still immense. So we wish and we're looking forward to have a more efficient process to automate certain manual process steps and push, as I said, the dotted line always towards more quantity and better applications.
Yeah, I fully agree with you. That's why Materialise is dedicated to streamline the digital process even further by cutting down the manual effort, as you just said, in data preparation and making the overall process more efficient. And I'm pretty sure we will continue our great relation in the near future. So thank you, Kai, for stepping in again and for the presentation as well and the insights you shared.
Thank you.
Thank you so much. Two of you, very inspiring. What I like most, to be honest, is that you tackle different application. And I think it's always important to mention that it's not the big thing, that's sometimes the small thing. Just one question from my side before you let you go. The horse, the nose strap, is that something that is asked for very often, or was it just how many times is it sold? Let me put that question.
Well, as I said, we did not know this application. This is something we developed together with a customer who was looking into 3D printing, said, I have an idea, can you help us? And similar applications we have a lot, which from not so common areas. Yeah. So as I said, we are in aerospace, we are in automotive, but really fun thing and funny applications are in industrial applications or consumer applications, which are not that common. And there we see high profitability because it's a traditional market where no one expects 3D printing to be used.
Very good. Thank you so much, Kai, Dennis. It was a pleasure to have you here. See you later on. Thank you so much.
Okay.
Thank you.